So the first thing I'm going to do is rewrite the square root of x times x, because how many of you, that part scared you? What is the square root of x times x if I add exponents? X to the 3 over 2. Algebra first. Yep. Algebra first. Why does that help a lot? Make sure, because you originally had to do a product rule to do that derivative, which was pretty nasty. And now I can just let u equal x to the 3 halves power. Du would then be 3 halves x to the 1 half dx. And that is great news. Why is that great news? There's the square root of x right there. That's the square root of x. I made a good choice. So now I can rewrite. Oh, sorry. I should finish this part. 2 over 3 times 1 over x to the 1 half du equals dx. You can solve that however you wish. Somehow you got to get dx by itself. So I have 2 over 3 is 1 over x to the 1 half du, and the x to the 1 halves cancel. So then I have 2/3 integral e to the u du. Wow, that's not so bad, is it? Which one?
The 2/3, like how you put it outside the rule.
You don't have to.
Because you just ended up writing it as 2/3 even.
I'm just putting it out there so I don't have to think about it in the antiderivative. I don't have to think about the 2/3. But for e to the u, it doesn't matter. But for something else, you might get caught up in trying to.
Okay, because the number. Because it doesn't matter.
If I, like, to show my work, can I draw the graph?
Yes. On the solving, is that what you're talking about? Any questions about that one?
So you took the... When did you take the derivative of
the antiderivative? Well, what is the antiderivative?
It's the same.
Right, so...
only has x, like when it has x.
Good question. Only when the variables match. You see how I'm doing the derivative, the du, e to the u du? So those are the same variable, and so it's just e to the u. Okay, the last one. And the last one is particularly horrible, but I am guaranteed that I can do this with u substitution, or it wouldn't be in Cal 1, right? Now I will tell you, this particular problem, because that's a cube, there are great merits in just multiplying that out. And I probably would do that if this came up. But why you still need this skill, and eventually someday I'm going to change that slide to be like a 12th power. Right? That's where you would really want to use substitution, because you don't want to do a 12th power. So I'm going to pick the 4x minus 5 because I really don't have another option. It's in that cube. But the problem is, what's du? 4. Why is that a problem? There's not an x. So that x is not going to cancel. So I've got a problem. And there's a reason we didn't do this one yesterday, because I didn't want to confuse you. You can try it. You still don't get anywhere though, do you? So I'm going to just write it and see what happens. Oh, that's not a fifth, that's a cube. I cannot work this with two different variables. However, if u equals 4x minus 5, is there any reason I couldn't find out what x is in terms of u? Would you agree with that? Now, most of the time, what I just did there would be a waste of time because it seems like I might not have simplified anything. However, what this has done, it has taken the complicated part out of the power. Why is that good? Well, let's look. I'm going to go ahead and just move both 1/4 out here. Yeah, this 1/4 u plus 5. Now before, because the complicated part was cubed, I would have had to do a 3 times FOIL type problem, right? And that would be yucky. Is this hard to multiply now? Now, and you could imagine if that was a 12th power, how much we've really simplified our lives. With this one, I don't know, you could make an argument that you could do the algebra faster. But this is just u to the 4th plus 5u cubed. So what I've done is I have swapped variables to get a single variable under the power. This same trick works great to get a single variable in a denominator, because then I could divide by the number. So this trick, it's not a good trick, but it works very few cases. But the times it works is when you have a complicated portion under a power or a complicated portion in a denominator, and then you're still going to end up with a complicated piece. It's just in a workable position. So you're just moving the position around. So this one's a strange case of u substitution. Y'all getting good at anti-differentiation? This part? Any questions? Do you see why it is what it is? Because you raise the power and then divide by the new power. What was u? 4x? And again, it doesn't matter whether you group the c in the parentheses or out of the parentheses. It's the same thing. Putting my u back in. So that one was a particularly challenging one, but important nonetheless. Okay, any questions about those? All right, we're going to grade homework, and then you'll have a work day to finish your u substitution.